Hi friends, welcome to my channel Ask2Shamik. Today I will create a new series which called the Microservice series. I got a lot of requests from my viewers and my friends to create a microservice series in English, as I have a microservice series in Bengali, but this is only intended to the Bengali viewers. I thought that why I would not create a microservice channel for my non-Bengali viewers. So here it is. This is a new series on microservices where I will uh, give you rich content and every details of the microservice components. So today this is the first video and we will focus on why microservices, why we need microservices and why microservice is a buzzword today. We all know that Amazon, Netflix are the pioneer companies who are adopted the microservices technologies, and after they have successfully implemented that microservices, any other company or organization now starting to adopt the microservices. But question is why the microservices is so much heat these days? Why? What's wrong with our traditional systems? To dig down these things to understand what microservice offers and why microservice is buzzwords, we first need to understand what are the pain points of the traditional systems. In this video my focus would be to give you some pain points of the traditional systems and what are the main criteria of those 21st century softwares, and how microservices offers those software. So let's begin with why microservices. To, Before start, just I give a crisp definition of what we mean by microservices. Okay, so microservice is an approach to develop a single application as a suite of small independent services where each services can be independently deployable and communicate with others using a lightweight mechanism. So what we understand from this definition is that microservices means there is no single code base, rather than there is a multiple code base, and each code base is an act as a service which can be independently deployable, which is not dependent to any other services, and which has its own database and own code bases, own deployment mechanisms. And when one service is try to communicate with other service, they do it by a lightweight mechanism. What is a lightweight mechanism? Either it should be a sync REST API or it is an async JMS API. So pipe, the communications pipe should be dumb. It should not do anything other than carrying the payload. So now let's see what we expect in our 21st century software. So what should be the main traits of 21st century software? So first things, what we need from a 21st century software is the scalability. So the scalability means that how easy you can scale your resources in a different axis. So you may have heard that the art of scalability. There is a three-dimensional scalable possible in your software. It may be a horizontal scalability, it may be a vertical scalability, or it is a z-axis scalability. So in any way you can efficiently use your resources. Suppose in a normal day your software runs with 10 servers which can handle 1,000 requests per second. Okay, so for a particular day where your load is unexpectedly high, say 10,000 requests per second, then how easy you can scale your software? Say how can you add another 50 servers to it, or how you can channelize your flow into a particular geolocation. So as this, maybe these occasions is in located in Asia, so you want to channelize all those loads into the Asia. So how you can do that, how easily you can do that? It's called the scalability. So second part, its calm is in resiliency. So resiliency means how stable your system in case of a immense load. As I said, for a particular normal day your software serves 1,000 requests, that is well. But in case of 2 lakh requests, it comes suddenly, then how your system reacts? Is it gone down, or it should be stable enough, or it should what will be the response time of your software? Those will be measurable by the resiliency of your software. Now the third thing is the responsiveness. The responsiveness means that your software should be always responsive to your users. Means it should not be blocked the main thread, that user thread where user is operating in your GUI. It should not be uh, user should not be wait for a single minute or single seconds, because user is most critical things in your software, and he is the main priority thing. So if he has to wait for a 1 second, he will never visit your software again. So the responsiveness is the main thing for a 21st century software. So you have to pay attention how you can keep your system responsive. Now the fourth thing is that there should not be a single point of failure. So what does it mean by the single point of failure? The single point of failure means that your software should not be down. It should be up 99.99% up through the year, day by day, year by year, because there it can be happen your software can be partial failure, but it should not be a single failure. If your software is gone down, then your valuable time is lost, your users valuable time is lost, your users transaction may be lost. You need to the recreate of those loss scenarios. So it is means your revenue loss, it means your user dissatisfaction. So it's a hail mess of things. So don't do that. So opt for no single point of failure architecture. That's why the microservice comes into the picture. Because I am not saying that using the traditional architecture you cannot get all those things: scalability, response, resiliency, responsibility, responsiveness, and single point of failure. You can achieve that, but it is hard to achieve rather than using the microservices. Microservice offers these things very easily. That's why the microservice is currently a buzzword and everyone is running behind the microservices. So now also there is also other reasons why we choose the microservices. So let's understand what are the common pain points of a traditional systems, what we call quote unquote the monolith system. Okay, so the first pain points of a monolith system is there is one code base. I am sure that you have worked on in a monolith architectures. It's in monolith architectures means you have to download the code from your RTC or Git stream as a whole, as a old code base. It's maybe a multi-module project. Say we have building a student registration program. Okay, so in student registration program there should be a multiple modules, like one is account registration module, one is your payment module, one is your notification module, and different teams works on different module, but they commit the code in a single code base. There may be a single code base, there may be a multi-module projects, but all developers are commit in a single stream. So when you try to run that software as a whole in your local system, then it should be a big problem, because you only work in an account registrations module. You do not know anything about the notifications module or payment module. But when you are uh, download or clone the projects in your local, you need to make those models error free, but you do not know anything about that module. So you need to seek help from that notifications modules developer or other modules developer, so which is a time consuming and which is a gigantic task to do. So that is the first pain point of a monolith architecture. And again, the another point is that suppose you are working in an account module. There you need some tweaks needs to be happen to fix your bug. So you do it, but as this is an 1 year which contains multiple words, you need to rebuild your whole system. And you may be experiencing that in a software architecture, in a monolith architecture, when you rebuild a system, how slow it is, how many time it takes, and then you create a one fat year, then you need to create an incident, you need to put give that year to your ops team, then ops teams will promote that things to the higher environment. So that is the pain point of a monolith service, because there is in one code base. As this is in one code base, it is not very manageable. Now, the second is, as I said, just this is another deployment issues, because it's a simple change. You need to deploy whole artifacts, all words to generate a yard and promote it to a higher environment. Also, in a traditional system, there should be developer teams, there is an ops team. So you need to raise a INC, you need to give that ER to your ops team. If other developers team gives an another versions of years to that ops teams, then it needs to be patched with that year. So it's kind of an hell of a situation, synchronizations of different things, synchronization of the different things, because there is no individual deployment pipeline or individual deployment resources for your individual teams. There is one shareable resources, and everyone try to promote their own version of snapshot into that particular system. So here is the deployment issue we generally face in a uh, monolith architecture. So now the third point is the Conways law. So what the Conways law says? The Conways law said that your architecture mimic your organization structure. What that does it mean is like that. So if you are working in a service company, you are experiencing that there is a different kind of expertise, and they have a different kind of pools of that expertise. Means if you have an UI pool in your organization, you may have a Java pool or microservice pool for your Java developer or middleware developer. You may have an DBA, database administrator pool for the database. So, and when a project is assigned to that organization, you just pull some developers from each pool and form a team, and then you start working on the that particular software. So what problem is that the main problem is the politics of the nature, because as there is three different segregated teams, you are building a layered architecture, a UI architecture, a middleware architecture, and database architecture. And when you are trying uh, to architecting your solutions, every architect, the UI architect or your middleware architect or your database architect, are trying to keep the main business logic into their end. So they are in a driver's seat in a problem. When there is a problem, they should be the focus, and they will provide the solution. So rather than doing a proper architecting, they are biased to keep the main business logic into their end. It's maybe they wanted to do a thick client, it may be wanted to a thick database layer, they write so much script in there, so it is so much bulky that it tends to a faulty architecture. So that politics comes in when you are maintaining your organization a different pool of expertise. That is the Conway's law says. And another problem is that suppose you are developers projects and it is deployed in the production, and after a few times a critical bugs comes in, so the blame game starts, because UI team want to not take the blame his end, so he delegates that ends to your middleware team, and your middleware team then sends saw the problem, and then he's hand over to another middleware team that this is not mine, this is for this particular module, this particular module maybe delegate this problem to the database layers guys. So it's the all the means different ball game. So everyone do not want, rather than solving that or focusing the into the problem, they try to push that problem to another's court, because they want to be free from that particular critical bug, and they do not want that organization should pointing their team. So that's why the blame game starts and the politics comes in when you are following uh, following that layered architecture in your team, and there is a layered pool of resources in your organization. Now, the calm is that another typical things I saw in organizations, every organization, is that there is a development team and there is a support team. So what development team is do is they develop that their projects, and then they put a 2 3 months KT to a support team, then just move out from this project and start to building a new project. So it is now the support team's responsibility to maintain that particular microservices or particular project. So what is wrong with it is that it is not possible that the software you are building for a 2 3 years, within the 2 3 months you cannot give the whole KT to a support team. They absolutely does not know the every in and outs, every trickery of the development codes, what they did. Okay, so in a critical situation, when a critical bugs occurs, so you need to opt help from the development team. But the problem is like that at that time that developers guy or that developers groups is building another software. So what's happened is that he may forget that what he did in that software. So the problem is that they cannot solve it is in just a blink of an eyes. He cannot identify the main point, main problem. So overall the company organization reputation is gone down, and it's create a several loss for an organization. Maybe some projects are gone away for this only small incident, these supportive and developer teams cultures. Okay, so now I am coming to the microservice benefits. What are the, I mean, these are the pain points we now know in a traditional system. Now I try to show you how the microservices try to solve those things. So you know that, as I said, that microservice means that each service is an individual project and it has its own encapsulated database. Means each service is can be built in a different programming language and different databases. Maybe one services it's built on a Scala and a GraphQL. Then another software, another services maybe can be built in Java in a relational database. So according to your need, according to the project's need, you can choose your programming language, you can choose your database and works on that. Means you are not confined in a single database or a single programming language, which is the main fault of an traditional architecture or monolith architecture, because monolith architecture means one code base or one database. That's why you need to choose at in from where, means before coding, that what should be your database and what should be your programming language. And in the middle of the something, if your programming language does not support a feature very well, you have to find any bypass way to fit in rather than opting another new languages. So this is the polyglot nature of the microservices. Okay, and another problem is that developers only focuses another benefits of a microservice is that developers only focuses on its small code base. Because if you are working in the account module, you only download that account module code base and works in it. Because, and as this is an confined a small code base, you know the in outs whereabouts of this software, this code base, you know what is building here, because everything is in your hand, you know everything. So there should not be any time wasted for clearly means clean it up, means clean it up the compilations error or build it in the local. Also that system every service has its automated pipeline to deploy. Maybe a Jenkins they opt for, means once a developer checks in a code, it will be automatically triggered the build and deployment augurs. So there should not be a ops interventions here, because the microservice welcome the DevOps culture. So now the another things microservice offers is that you build it, you run it, means there is no developer and supporting concepts. If you develop a microservice, it is your duty to support it all along all of your life. So it is necessary that you should build your things very well. Otherwise, if you build your things not very well, in a support time you will got the pain. So developers, and as this is a cross team, your developers, your UI developers, your database developers are work as an unit, so that they can build a such seamless product that which cannot give a trouble in a post production days. So they are very careful about it, and it increases the quality of your services. That's all the microservice benefits it's offered. So I believe that I can give you a holistic picture is why we need the microservices architecture, and what our 21st century's architectures are needed, and how to build that. In our later videos, I will share all the microservices components, how it works, how you can develop those things using the spring boots, all of things. Keep watching, and if you love this video, then don't hesitate to subscribe in this channel and just hit that bell icon, so you can get notified my next video. So till now, it's bye. Thanks for watching Ask to Shamik.